Hi, welcome to Team RoboMaster. We are a team that dedicated to make a 6-axle robotic arm. Everything is 3D printed from scratch. As you can see, the operator is using a joystick that we made from scratch to control each of the 6-axle movements. On the head of the robotic arm, it has electrical magnets. So take a close look at the circuits. We have 6 stepper motors, 1 LCD connecting using SPI to the microcontrollers, and we also have onboard 5 volts and 30 volts regulators. And then we have this joystick, which contains 2 joysticks and 2 buttons. And you can see there's also big buttons. You can see the red one. That one is for emergency brake. In case anything happen, you can just stop it. So like this. So yeah, once you hit it, it will stop. So take a look at the mechanical structure. We have mostly 4 stages. At the bottom stage, I can rotate. Second stage, I can also rotate back and forth. The third stage will do the same thing at the second stage. So you just control the robotic arm using the controllers, and you're all set. Now let's take a look of the PCB design. First, let's take a look at the main controller board. We're currently using the software Eagle as our PCB design software. Inside, we have 2 layers. The red will be the upper layer and the blue will be the bottom layers. So on the right side, we have the power inlet, 12 volts, one feeding to the motors, another one feeds to the microcontroller voltage regulation systems. So right now we have a circuit block that deal with voltage regulation of 3 volts. So step from 12 volt to 3 volts. We also have this, which is a 5 volt regulator block that feed to the main controllers. And in here, we have 6 A4988 stepper motor controllers, which is used to drive all the motors. And on the left, we can see this area which you want to connect your STM32F0. At the bottom, here is where you connect to your joystick. And then here, LCD adapter, obviously we're connecting this to the LCD. And finally, on the OLED part, we have all 9 opto diodes for the limit switch and limit sensing. So all the motor controller have 100 microfarad, 25 volts capacitor connected to it to prevent sudden voltage drop in the systems. And then we have these jumper wires that you can select microstep. This one is a servo motor drive outlet for the servo motors. For example, you might want to put this on your servos at the front of the robotic arm. So this is for driving servos. That's pretty much it for the PCB side of things. Hi. So this part I will introduce more on the mechanical aspect of the robots. So here you can see all these 3D printed files present between your eyes. So this will be at the first stage. So you can see 3 motors run over here. And we have the first stage gearings. This is the motor shaft. Covers for the second stage. The entire 3D printing process took a little over 2 months for on and off. We use over 4 kilograms of PLA combined with PETG materials for high temperature bearing. Like the stepper motor can get really hot. This will be the base. As you can see, there's a lot of ventilation going on in this robotic arm. Have a lot of places to place the fans. Yeah. So other than the 3D printed part, we also need bearings, belts, screw and nuts, also rods. So we purchased these off the internet. And the entire building process take a week, and the material gathering take another week, and then 3D printing takes 2 months. Now let's take a look at the softwares. So here is 2 main files that we have. So one is the main.c, another one is the motor.c. So the main.c we have basically had the ADC read, ADC init, joystick readings, you need GPIOs, movements, initialize all the motors basically. And in the main loops, basically have a while loop that's just reading the inputs all the time. So on the motor side, we have the update timers for updating the frequency and the duty cycles. On the update motors, for different type of motors, we have different type of function to call. This is for the alternative function settings, GPIO motor setting, also calling the functions, timer initializations. Yeah. So the code basically can explain how the motors work. All the motor drivers take PWM signals, and we manipulate the duty cycles and also frequency, and also the delay between the pulse widths to determine the spinning speed and or step per seconds of the motor drivers. Thank you so much for watching. Have a nice day.